Alright, we're back and we're finishing up, getting ready to finish up Chapter 10. We only got a couple sections left to go. 10.5 is today. We're talking about finding the probability of independent and dependent events. And when you think about the word independent, I hope you think of freedom or being free of other things. Okay? And dependent means you're dependent upon others. You need other people around, or you need other things around. So those, if you had those definitions in your brain, that's going to help you get through this stuff. Independent events are two events such that the occurrence of one has no effect on the other. Let's just go with free from each other. Okay. Two things that are free from each other. Alright, independent. And dependent events, they affect each other. They have, they have an impact on each other. So let's say impact upon one another. Okay? And conditional probability is the probability that event B will occur, given that event A has occurred, is called the conditional probability of B. So if this has already happened, what's now the impact on the other one? So will one thing affect the other thing, type of thing? Okay, so let's see how that goes. The probability of independent events. That you'll notice that this is going to be different. The probability of independent events, and look at, we have that word and. And I hope you remember that we've already been talking about that. The probability of A and the probability of B means we're just going to find the probability of A and multiply it by the probability of B, because it's and. More generally, the probability that n independent events occur is the product of n probabilities of the individual events. So we're going to say product right here. I got this little skit for us here. Got this. It's graduation day, and the perfect attendance award goes to Scott Shaw. I must say there. Scott. So Scott skipped out on graduation day. I thought that was kind of funny. All right. Every morning, one student in a class of 24 is randomly chosen to take attendance. What is the probability that the same student will be chosen 3 days in a row? Well, the student has a 1 in 24 chance of being chosen on the first day. Now, on the second day, he also has a 1 in 24 chance, and on the third day, he has a 1 in 24 chance because, let's say they're picking them with those cards or sticks or something. When you pull out a card, you put the card back in, your chances are equally likely. So your chances are 1 in 24 times 1 in 24 times 1 in 24, which, if you put that in a decimal, I think something like 0.00007. So chances of that happening, not very likely. But again, are completely independent. So if you did get picked 3 days in a row, what would be your chances of getting picked on the fourth day? 1 in 24 again. Now, if we didn't want to pick the same person each day, you would do something like pick that person's card and then leave it out for the next day. Then it becomes a dependent event. But these are independent events. All right. Let's take a look at this example here. Get rid of these things. This is a tricky problem. This has always been a tricky problem. Pay attention. Follow it closely. A manufacturer has found that 2 out of every 500 coffee pots produced are defective. What is the probability that at least one coffee pot is defective in the first 300 coffee pots made? So, manufacturer just knows. We're going to have a couple of these that are going to be bad. Nothing we can do about it. What's the probability that you're going to find one of them? Well, the probability of a coffee pot being defective is, or not being defective, being a good one, is 498 out of 500 coffee pots, or 0.996. I'll change this to blue. Each coffee pot made is an independent event, so the probability of making at least one defective coffee pot is the probability of making a coffee pot is defective. It would be the 1 minus the coffee pot not defective to the 300th power. So it's that 1 minus 0.996 to the 300th power. And if you did that, you get 0.700. So remember what the original question was? What is the probability that at least one coffee pot is defective in the first 300? We got about 70% chance that that's going to happen. All right. Let's take a look at this next one here. It says let's get rid of some of this stuff. During a high school track meet, here's one of my favorite groups of guys ever. During a high school track meet, each race consists of 9 competitors who are randomly assigned lanes 1 to 9. What is the probability that a runner will draw lanes 1, 2, or 3 in 3 races in which he runs? Well, if you have a 3 out of 9 chance of drawing those lanes in 3 races in a row, 3 out of 9 times 3 out of 9 times 3 out of 9, hopefully you saw that that's 1/3 times 1/3 times 1/3, but maybe you didn't. It would be 27 out of 9 to the 3rd power, which is 81 times 9, 729. All right, or 1/3 times 1/3 times 1/3, which is 1 out of 27, which is what this would reduce to. All right. Manufacturers found that 6 out of every 450 batteries is defective. What's the probability that at least one battery is defective? Well, you do that same thing you did earlier. 1 minus 444 out of 450. Remember, that's the 6 to the 100th power. 0.739. All right. Probability of dependent events. The one trick with this dependent events, you are multiplying them still. You still have the probability of A, but when you multiply, that we call it probability B conditional A. And there's this line here, like there's a straight up and down line that says it's the probability of B, but knowing that A has already happened, so you have to take that into account. So let's take a look at some of those random events, or those conditional probability events. On this one here, it says, find the probability that a listed person has blue eyes. Well, how many people have blue eyes, and then how many people are there total? Well, there's right here 44 people have blue eyes, and there's total 200 people. So you have a 0.22 chance. What's the probability that a male has blue eyes? Okay, so now you have to look at just the male. So this makes it a little bit more conditional. 35 out of 100 males, so that becomes 0.35. All right, that's one example. Here's example 4. You randomly select 2 marbles from a bag containing 15 yellow, so let's make a little bag here, containing 15 yellow. I'm just going to write this up. 15 yellow, 10 reds, 12 blues. Okay. What is the probability that the first marble is yellow and the second marble is not yellow? Okay. First marble being yellow, the probability of A would be 15. Remember, it's probability, not odds. 15 out of, it looks like there's 37 marbles total. And not yellow, we'll call that B. Probability of B chances of something not being yellow here would be 22 out of 37. However, there's some conditional statements here. If you replace the first marble before drawing the second. So that's A. Well, I have a 15 out of 37 chance times a 22 out of 37 chance. And when I multiply those two things together, I get 330 out of, gotta restart our, looks like our music stopped. 330 out of 1,369. All right, that would be an independent event, completely independent. One thing had nothing to do with the other. All right, and that was approximately 0.241. Now, the next way they said was you do not replace the first marble. So you took out the first marble, and that was 15 out of 37. But when you went to draw the second marble, the not yellow marble, there was still 22 not yellows in there, but there were only 36 marbles left. And see that how that second number changes. So that became 330 out of 1,332, which equals about 2.248. All right. So those numbers aren't a huge difference, but certainly this second one would be called a dependent event, and the first one would be called an independent. Completely independent and completely dependent. All right, let's take a look at what we got going on here. Pencils. Your teacher passes around a box of pencils with 10 reds, 8 pinks, and 13 greens. If you and two people in your group are the first to randomly select a pencil, what is the probability that all three of you select a pink pencil? Well, this is definitely a dependent event, because you take a pencil and you don't put it back, you take the pencil out. So your chances of getting a pink pencil, if you select it at random, would be 8, because there's 8 pencils, 8 pink ones, out of, looks like 31. But the guy next to you doesn't have 8 pencils in there. He only has 7 pencils, and there's only 30 pencils left. And the next guy, there's only 6 pencils left, and there's only 29. Or there's only 6 pink ones and 29 pencils total. So you see how those were dependent on each other. And if I did all the math on that, I would get 336 on the top and 26,970 on the bottom, or 0.0125 would be the chances of that. You guys go ahead and take a look at these examples, these checkpoints here. I'm just going to give you the answers on those checkpoints, and then we can talk about them. If you use that table, you got a 41% chance of picking a female that has hazel eyes, and both marbles being yellow. If you replace the first one, remember that's an independent, so make sure you have put that marble back. And B, they said if you do not replace it, so that's a dependent event. Alright. And in example 5, what's the probability that you and your group member all choose a red pencil? Do the same thing we did with the pink ones, but do it with the red ones. And I hope you got 0.267. I'm going to be looking for some work tomorrow on these things. Otherwise, I know you just copied down my answers. So I hope you showed your work. Thank you very much, folks.